Good morning. I'm Eli Remolona of the Asia School of Business. We at the ASB and especially the Master of Central Banking Program and SEACEN welcome you to this webinar by Frank Warnock. We are privileged to have him with us today. He is an old friend from the Fed. He was at the board in Washington. I was at the New York Fed. Now Frank is the James C. Wheat Jr. Professor of Business at the University of Virginia's Darden School of Business. He is also research associate at the National Bureau of Economic Research. He is research advisor at the Federal Reserve. He is also associate editor of the Journal of International Economics. When I was at the BIS, Frank was a great resource for us. He was our consultant. He has also consulted at the European Central Bank and at the IMF. Before coming to Darden in 2004, Frank was senior economist in the International Finance Division at the Board of Governors of the Federal Reserve. His PhD is from the University of North Carolina at Chapel Hill. Frank is famous for his work on international capital flows, international portfolio allocation, and financial sector development. Related to that last topic is his work on financial inclusion, which I also admire. Let us please welcome Frank. I don't know if his co-authors are with us, but let us welcome them as well. Frank will talk about KF star, the natural rate or the natural level of capital flows. Frank, Oli, did you want to say something, Oli?
Okay, sorry. I will say my words of admiration at the end.
Okay, Frank.
Okay, so thank you, Ellie and Ali, for the invitation. It's great to see you. And I will say that, so this paper is, as Ellie mentioned, it's joint with John Berger and Veronica Koktok-Warnock, with whom I've written many papers. And this is KF star, the natural level of capital flows. I have to thank Ozair of SEACEN, who actually made this suggestion when I presented an earlier version last April, a year ago April at SEACEN, and Ozair made a wonderful suggestion that actually reshaped this whole research agenda, and so I have to give a special thanks to Ozair. Okay, good. So this is going to be based on two papers, right? Because I think it's kind of hard to understand this without going through both to some extent. So one is the original paper called Benchmarking Portfolio Flows that we wrote and published in the IMF Economic Review in 2018. And two is the current paper, which is called The Natural Level of Capital Flows. And you notice what I'm presenting is a September 15th, 2020 update, which we haven't gotten December 15th to September 15th yet. So that is, I'm presenting some stuff that's very much in progress, but will be finalized in the next 12 days, is my prediction. Okay, so the outline is, so first I'll talk a little bit about the 2018 paper, and that gives a benchmark for annual portfolio inflows, annual being an important word there. And then we'll go to the current paper, which brings us to quarterly capital flows, which are notoriously volatile, and tries to see if this measure helps us understand those notoriously volatile quarterly flows. And we'll go through a number of different tests to show that it's actually a pretty strong measure. So this paper, this whole research agenda started a few years ago when Maury Obstfeld, who was then chief economist of the IMF, he asked us if the sharp decline back in 2015, 2016 in portfolio flows to emerging Asia and Latin America, the sharp decline that both regions saw, were they likely temporary or likely to persist? And so in this graph, so off to the side, I note that in this graph, these graphs, the data are balance of payments portfolio inflows, that is debt and equity inflows. And keep that in mind for the rest of the talk, because that's what we're focused on. Portfolio inflows into various countries. These graphs are aggregated up to regional levels, but we do these for individual countries. And so the question that Maury asked us was, this sharp drop, do you think it's going to, that's the new normal, or is it going to bounce back? And we didn't know how to think about that. And how does one actually go about assessing whether a sharp decrease or any sharp change in capital flows is an aberration or is the new normal? And our answer was to develop a benchmark, that in some sense represents the normal level of capital flows. And once you define normal, then you can say whether this sharp drop was away from the norm or towards it. And in fact, so our benchmark is the slower moving slower moving blue line here, less volatile. And what it showed actually back then, so this is back in 2015, was that the decline in portfolio flows to emerging Asia far overshot the benchmark. And so we predicted based on that those flows would rebound, whereas in Latin America, the right graph, the sharp drop was back to the benchmark. So it was back to normal. So they were getting abnormally high flows, and it just dropped back to normal. And so that's what, in our original paper, and I'll talk a little bit more about it, but that's having the benchmark allowed us to take a stand on whether the decline in flows was normal or an overshooting. And if you roll forward from there, right? So the previous graph stopped in 2015, but what you then saw was a very strong resumption of inflows in emerging Asia, where, as we would have predicted, and in fact it overshot. And in Latin America, the flows stayed right around the benchmark, right? And so so having a benchmark, we would say, helps distinguish between movements towards the benchmark and movements away from the benchmark. Anything away from the benchmark should dissipate. It should reverse in time. And when I'll be more specific about that statement as we go forward. Okay, so what is KF star, right? So right now, let me go back one slide. Right now, I've drawn this blue line, this slow-moving blue line on these graphs, but I haven't told you what this benchmark is, or what we're now calling KF star. KF star, simply put, is just current period rest of the world private savings times a lagged portfolio weight. That is, so if we take a step back and think about it first, rest of the world savings is the new amount of money that's available for new capital flows. You can have other capital flows. You can decide to reallocate your portfolio away from one country towards another country, or away from your country towards another country. That will create cross-border flows for sure. But the new bucket of money that's available is really just rest of the world private savings, right? So if you're sitting in Malaysia and think about what's the new amount of money that people have outside of Malaysia to invest in Malaysia, it's really the savings that they're generating that year. So that's the rest of the world private savings. And we just hit that with the lagged portfolio weight, actually a 5-year moving average. And that is then the KF star, right? So if we go back to the preceding slide, that blue line is just rest of the world private savings times a 5-year lagged moving average of portfolio weights. The portfolio weight, this rest of the world weight, is just If we pick Malaysia, for example, it'll be Malaysia's portfolio liabilities. So through the IIP data, right? What are their portfolio liabilities? Divide it by rest of the world wealth, and that would be the rest of the world's weight on Malaysian bonds and equities. This 5-year moving average, or just note parenthetically at the bottom, is actually similar to what CBO does. So in the U.S., the Congressional Budget Office, when they create potential GDP series, they create potential GDP series from the supply side, and you could think of Y equals AKL, and so and with exponents on the with shares on the capital and labor variables. But the capital share and the labor share is very volatile, and so what they do is smooth that out, and we're doing the same thing in a sense. We're taking these portfolio weights, which can be very volatile in a given year, and just smoothing them out, just using a 5-year moving average. Okay, good. And this just gives more details. We don't necessarily have to get into the details. If somebody's wants to ask about it, I'm happy to go into it, but this is pretty much saying the same thing, and it's just telling you where we're getting the data. There's nothing difficult about our data set. There's everything's publicly available. Flow of private savings we get from the IMF WEO's data set. Rest of the world portfolio holdings, you could get it from IIP, or we go to Lane and Malesi Ferretti just because it's one, it's easy, and two, they have more countries. And so that Lane and Malesi Ferretti data set is actually the constraining factor on our ability to create KF star, and it's not much of a constraint because they have data for 180 countries. So we can create KF star for 180 countries, and some of them don't actually report flow data, but we don't need flow data because we don't need their data in a sense. We just need an estimate of rest of the world portfolio holdings in that country, which we get from Lane and Malesi Ferretti, and then we need rest of the world savings. If the country doesn't report savings, that's okay. I can assume that in global savings, they are epsilon, and so I still have a good sense of rest of the world savings. Scale factors we get from this Credit Suisse data, which goes back to 2000, and that's pretty much it. And there's a lot of decisions behind this that had to be made. A lot of different things that we had to think about. All the details are in the 2 papers. I'm happy to talk about them if you want to, but I think I think if you understand this one equation, then it's pretty straightforward from there. And now I'll pause in a second, but I'll just show you what we get for these KF stars. And so in the euro area, the KF star, so this is what we call the benchmark, where we think that the flow should oscillate around, increased a lot through 2011, and then flattened out from there. And some other places, like Korea, for example, the bottom right graph, it kept increasing, and emerging Asia, the bottom graph here, kept increasing as well. I'll pause there for a second in case there are questions on understanding where this KF star is coming from. And then what we're going to do going forward is try to understand, does it actually help us understand where actual capital flows are going in the future?
I have a small question, Frank. The 5-year moving average, is there anything special about 5 years? Is it does it matter if it's 6 or 4?
No, it doesn't. And so in the original paper, we tried 1, so just a simple 1-year lag moving average, 3, 5. It doesn't matter. So if you go with a really short moving average, then your KF star is going to move around a lot more. And we want it to be kind of slow moving, right? So we said, let's just go with the 5-year. But there's nothing special about it.
Hans Genberg, who's also here, has a good question. He asks, how come KF Star in Europe stopped growing in 2011? Was it 20?
Yeah, roughly 2011. Yeah.
But
So
in general, are you also going to talk about the behavior of the benchmark itself, the behavior of KF Star?
not as much. So let's see. Let me just go ahead. So here, so this will get at Hans's question. And Hans, it's I would say it's nice to see you, but I can't see you. So this is, so there are two components to KF Star, right? So one is these lagged portfolio weights, fine, that's one component. Two is the rest of the world savings. This graph is of rest of the world savings, or global savings from 2000 through 2019. And so Hans, what you see is that that global private savings peaked in 2011 and then was flat for 5, 6, 7 years, and even declined 2016, 2017, 2015, 2016. And so that means that for any country to have an increase in KF star after 2011, it would have to be because their portfolio weight, the rest of the world's holdings of their securities, had increased greatly, right? And so what you see is that so if we go back to Europe, in the through 2011, even for constant portfolio weights, rest of the world savings was growing fast enough that you got a sharp increase in KF star for the euro area. But after that, after 2011, when private savings was flat, it would have to be increased portfolio weights to generate an increased KF star. Now, you do see those increases in the US, in Korea, in emerging Asia, the bottom graph here, and other places, not in the euro area, right? So that's the reason. So good. All right. I will move on. Yes, I will move on. And this just puts sheds a little bit more light on Hans's question, and says pretty much what I just said, so, which is good because I wrote the slide. All right, and this is then for emerging Asia and Korea, and again, so there's two components to it: rest of the world savings, which has been flat since 2011, and this lagged portfolio weight, which for some countries, some areas has increased. For other countries, it has not. Okay.
Sorry, Frank, can I stop you for a second?
Yep.
Uzair made a good point. I mean, again, tying up with Ellie's question, and actually I wrote the question down whether, the length of the moving average matters. I mean, you can use, as Uzair said, you can use these Cogley tests to sort of look for the optimal size of the moving average window.
Perfect. Yeah. That makes perfect sense, and we hadn't thought about that, but absolutely. Okay.
And then I had another question. I mean, you're looking at levels. Does it make a difference whether you're working in levels or differences? It's nominal or real. Does that enter into all these calculations?
What we're going to predict is actually going to be the change in flows going forward, right? So I'll show that in a few slides. We're always working in just millions or billions of US dollars, so it's a nominal level. So it's the balance of payments, capital inflows, portfolio inflows, right? So just debt and equity portfolio inflows. We've found that we don't actually have to scale it in any way for it to be useful. Okay, good. So so we're going to start to segue to the 2020 paper. So the 2018 paper created this benchmark, this notion of the benchmark, and it did it for 47 countries, and it showed using annual data that there was a significant in-sample long-run relationship, co-integrating relationship between actual flows and the benchmark, and that the benchmark helped predict the direction of one period ahead changes in inflows. One period in that was 1 year, right? It's an annual data set. And so that's all well and good. It's a useful paper. What we're going to try to do in the current paper is push this further by trying to apply this notion to notoriously volatile quarterly portfolio flows. And when I say notoriously volatile, this is what we're trying to help people understand, right? And you take one look at this. So this is just quarterly portfolio inflows into Japan, China, Indonesia, India. And you'd say you're crazy for trying to actually model this. And if you go through a lot of the literature on capital flows, it's trying to model these quarter-to-quarter changes. And usually you get an R squared. Often you get an R squared of 0, but sometimes maybe you're lucky and you get to 0.07 with an R squared. It's very, very difficult to model, and that's what we're going to try to do with our KF star. To preview, just to get on the table some of the different features, those quarterly portfolio flows, they do oscillate around KF star. The deviations are transitory. The flows will revert back to KF star over a 1 to 2 year horizon. The explanatory power of KF star in explaining the change in flows over a 1 to 2 year horizon is substantially greater than traditional push-pull factors. It also predicts 6 quarters ahead sudden stops, next year's equity returns. At the eve of GFC, it predicted the amount of flows that countries would get during the GFC crisis, and we apply it to the eve of the pandemic, and I'll get to that towards the end of the talk. But these are the different things that we think that KF star does, and the rest of the talk I'll try to convince you of that. Okay, so with the quarterly portfolio data, so what we get is, so we have a quarterly version of KF star. If you look at Japan, the upper left, what you see is that KF star would suggest that Japan should get about $50 billion a quarter in portfolio inflows, and you see that it oscillates around that. China, the upper right graph, looks like about $18 billion a quarter. For the past couple of years, it's been much higher. In 2020 Q1, it came back down. So the last data point on these graphs is during the pandemic, so it's Q1 2020. But for all these countries, even though the quarterly flows are very volatile, they oscillate around KF star, and we'll show this empirically, and we'll show it through these Cogley tests that Ozair pushed us to use a year ago, April, and I'm eternally grateful to Ozair for that. And then we'll also show it with sudden stops and equity returns. Okay, so the Cogley test, and here's where I wish that Ozair could just present this. But so my understanding of it is, so in the original JMCB that Cogley wrote, it was trying to get the predictive power of different measures of core inflation, right? So headline inflation is very volatile, it jumps around, and it's very difficult to extract the signal from the noise in a volatile series. And so we have various measures of core inflation. And the whole idea, if you look, let's see, I actually have a pen, so let's see if I can do this. We have a few different things. Oops, it didn't work. Let's see. My pen doesn't work. Yeah, I don't need it. Okay, that would have been fun. But anyway, let's see. Oh, there we go. So the whole idea is that if you have some if you have some measure of core inflation, call it pi star, it should equal the expected value of headline inflation, of actual inflation, H periods ahead, right? And so that's the whole idea. So that you find something that is the expected value of the underlying H periods ahead. If that's the case, then the expected value of the underlying H periods ahead minus the current value of that. So this is the equation in the middle equation here, should be equal to the negative of the deviation of the actual from core inflation in Cogley's example. And that would mean that if you ran a regression of the change, H period, so now I'm at the bottom equation, the change in inflation, in this case, H periods ahead, if you run that regression on the gap, so that beta H is multiplied by the gap, the time t gap, the current gap of actual inflation from core inflation, that beta coefficient, if your pi star is a good indicator, that beta coefficient should be -1, and that's what we'll focus on. We'll also look at the R squared from these regressions. This is just applying Cogley to KF star, basically just get rid of pi and put in flows, and get rid of pi star and put in KF star. But it's the same thing. If you get to the bottom equation here, it means that the change in flows between period t and period t minus t plus h it should be equal to the gap, the current gap, the negative of the current gap. That is, the flow should adjust back to KF star. And if it works well, then you'd expect in these regressions for beta H to be -1. When we do this, and I've inserted lines, horizontal lines, but so these are for the 30 EMEs in our sample, and on the x-axis is the forecast horizon, so that H, right? So this is forecasting out to t plus 1, and these are in quarters, t plus 2, t plus 3, et cetera, out to 12 quarters ahead. On the left side, we have the beta estimates, and that's all the beta. These are box and whisker plots, all the beta estimates for the 30 different countries, so the regressions are run individually. The line in the middle of a box, again, let me see if I'm not sure why I can't, let's see. If Veronica was here, she could figure out why my pen's not working. But anyway, the line in the middle of the box, let's see here, there I can use my hand to show it, is the median beta estimate. And so, and what you want for something that works, that is working well, is that beta to be -1. That's that horizontal line that we see. What you see is that the beta for the beta is pretty close to -1. The median beta is pretty close to -1 for a horizon of 7 quarters ahead. So that is today's gap between actual flows in KF star, forecasts ahead, the change in flows 7 quarters, which seems to be pretty good, right? And there's a bunch of them that are right at -1, right? But the median one is like -0.9. If you look at the R squared, the right-hand graph, the R squared is quite high, even for 1 quarter ahead. So the typical capital flow regression is predicting capital flows 1 quarter ahead. You typically get 0.07 or even lower. The median R squared for the 1 quarter ahead, and this is just a simple regression, right? It's just today's gap explaining the change in flows, H periods ahead. You get an R squared of median R squared of 0.4, and again at a forecast horizon of 7 quarters ahead, it's at its peak of about 0.45. Okay, good. Any questions on this? I'll pause here for a second.
Frank, I wonder whether you've tried to relate this to your work with Christine Forbes on surges in capital flows. I remember one variable that seemed to explain the surges was a kind of VIX. I don't think you used exact VIX, but something.
It was VIX, yeah.
Something like VIX, or was it VIX?
It was, yeah.
Good.
And I will. So I'll get to that application.
Okay.
Okay. So
Okay, so sorry, Frank. I have a question, not so much about the cognitive test, more about the actual deviations from KF star. I mean, I was wondering. I mean, I don't want to push this too far, but I mean, I reckon you could estimate sort of things like the half-life of the deviations, or maybe even the co-movement of deviations across different countries or within regions or something. I mean, again, I mean, this is not sort of a causal and this is not a structural thing, but I'm wondering whether sort of some movements occur first and then, or whether there's spillovers, KF star spillovers or something along those lines.
yeah, so we haven't thought about that yet. So those are good points, and that'll keep us busy for the next year. Yeah. Okay. All right. Good. Okay. So then we say, okay, well, let's do the same sort of thing with push and pull factors. So we just bring in some push and pull factors, and so the VIX, interest rates, equity returns, and we give those push and pull factors perfect foresight. So that is, they're entering as the change t plus h, t to t plus h, right? So they're trying to predict the change in flows to period t plus h. We give them perfect foresight. The Cogley graphs for the for the R squared, for the push and pull factors, are that left graph, And if you see on that left graph, the median, it's usually about 0.1, 0.2, whereas if we, on the right graph, it's back to the KF star, just the KF star, and again, it's 0.4, roughly around 0.4. And so much more explanatory power than traditional push and pull factors. Then we say, well, okay, there are other filters, right? And so, like Ozer's comment that we should try to figure out the optimal moving average for our weights. We can also think about other types of filters. So one is just so the first column is our KF star, and what we're plotting here, and what we're reporting here in these tables, are the average deviation from beta equals -1, absolute value of deviation from beta equals -1 in these regressions. That's in the top, and in the bottom is the mean R squared from the regressions, from running all these country level regressions. We've got KF star in the first column. We've got a 12-quarter moving average in the second column, a one-sided HP filter in the third column, and Hamilton's 2018 linear projection, where he recommends regressing something on, I think in our application, lags of 8, 9, 10, 11, 12, I think, something like that, from of the thing that you're projecting. And so what you want in the top portion of this is the smallest number possible. You want the smallest deviation, and this is 7-quarter ahead forecasting performance. You want the smallest deviation from beta equals -1. And you see for EMEs, KF star performs best. The Hamilton measure is good, is definitely a good measure as well. But the lowest value here is for EMEs is KF star. For advanced economies, KF star doesn't work as well, and we looked into why, and it's actually countries with unconventional monetary policies, which we define as either quantitative easing or negative policy rates, where KF star hasn't been working the past few years, and so it just doesn't work as well. For advanced economies that have not had unconventional monetary policy, it works very well, and so we kind of identified that. If you go down to the R squareds, again for emerging markets, KF star has the highest R squared, and those are very high R squared. Hamilton is a good measure too. So I would say one takeaway from this is that there is some underlying value, unobservable, let's say, that capital flows are oscillating around. KF star is a nice way of thinking about it. It's a structural supply side measure. Hamilton's linear projection model works well too, right? So if you take anything away from this, I would say from this talk, I would say take away that, wow, these quarterly capital flows actually oscillate around something, and KF star is a reasonable guess at that something. Hamilton's measure, which is purely statistical, is fine as well. All right, so gone through some of the Cogley tests, and from that we saw that the explanatory power was very high, and the deviations from beta equals -1 not that large, meaning that the gap does get closed in optimal 7 quarters. Next, we're going to move to predicting sudden stops, annual equity returns. I see a question from Hans, if we want to separate out the savings and the weights and think about that. I think Hans, we certainly can, and we've hesitated to do that because we're still trying to understand what the whole package brings, but we certainly can, and we've been pushed in that direction before, and so we should. Okay, good. All right, so predicting sudden stops. So basically all we're going to do, so if you go to the bottom line in this slide, Kristen Forbes and I have an update of our 2012 capital flow episodes paper, and what we're doing in this KF star paper is just taking that data set. So so Kristen and I always predict extreme episodes 1 quarter ahead, right? So all the regressions in Forbes and Warnock are set up to where everything on the right-hand side is lagged 1 quarter, and you're trying to predict whether a country is going to have a certain type of episode the next quarter. What we do in this KF star is try to see if the gap from KF star, so actual, I'm going to call this KF star gap, and it's actual minus the gap. Actual inflows minus KF star, we'll call that the gap. And we're going to see if that helps predict sudden stops and sudden surges. And because this is more of a medium-term predictor, we're going to try, we've tried to predict 4 quarters out, 5, 6, 7, 8. It works well for all of them. What we'll show is 6 quarters out. So it's not the 1 quarter ahead analysis that Kristen and I did, but going out 6 quarters. We're going to take the same variables that Kristen and I currently use on the right-hand side, and just put the current gap in there, the time t gap. But what we're trying to predict is 6 quarters ahead, sudden stops and sudden surges. For stops, it works really well. So this gap is statistically significant. So is global growth. And here's an important point. What we're predicting here is that when you have strong global growth, if you have strong global growth, you're going to have strong global savings, right? And so KF star is all else equal going to be increasing for a lot of countries, right? With global growth, global savings is increasing, KF star is increasing. What we're saying is, if in addition to that, you have high actual inflows relative to KF star, so you have a positive gap, you're getting more inflows than your KF star, so your KF star is increasing and you're getting more inflows, that is a strong predictor of a future sudden stop, right? So if you're strong growth, strong inflows, overly strong inflows, it's a strong predictor of coming sudden stop. How strong? If you go to so if you're in a situation where global growth is just one standard deviation above its mean, and this gap is just one standard deviation above its mean, then there's a 40% chance of a sudden stop in 6 quarters, right? So it's not even exorbitantly high growth or a KF star gap. It's just one standard deviation above the mean. That's a strong predictor of a sudden stop within 6 quarters. I'll pause there for a second. Any questions on this?
Not from me.
All right. I will press on given the time. So there's just 2 more applications I want to show. So one is predicting next year's equity returns. Hans had a question on the previous one. It's actually in 6 quarters that we're predicting. So we're just setting it up, trying to predict 6 quarters out. But I understand the in versus within, and we'll think about that. Okay. All right. So then we see this gap. So I said using KF star. It's actually the gap between actual and KF star to predict next year's equity returns. And so for this, we go to an annual data set, so we don't have all these overlapping observations. And so we just say, does the annual gap predict next year's equity returns? We control for lagged equity return, lagged returns, dividend yield, the VIX, country's growth, and we get a very similar answer to that we got in the sudden stops analysis. When global growth is one standard deviation, sorry for the typo there, one standard deviation, I guess not typo, above its mean, and meaning that global savings is increasing and all else equal, so is KF star. In that situation, if actual flows are growing even faster, meaning that we have the KF star gap, one standard deviation above its mean, the country's MSCI equity returns fall 9.6% in the next year, which is pretty big when I think the mean MSCI equity return in our sample, emerging market sample, is 8%, positive 8%. You get a negative 9.6% read the following year in that situation. And this is controlling for the sort of things you'd want to control for. So this is a pretty big response. When we first did this, we didn't control for all these other things, and the response was even larger, and people were upset with that. Now we've thrown in things that most people would have in regressions like this, and it's come down nicely to just a 9.6% drop. Finally, and this is the last application, we try to ask the reasonable question: will KF star help us think about what's likely to happen to capital flows in 2020 with the pandemic? To answer this, we went back. So the left side is back just prior to the global financial crisis. So what we plot on the horizontal axis of the left graph is the KF star gap in 2007, so right before the global financial crisis. And so countries that are more to the right, more positive on, more to the right, had much higher capital inflows than KF Star would suggest in 2007. And as you go to the left, they had lower capital inflows than KF Star would suggest. On the vertical axis is the change in capital inflows during the GFC period, which we define as 08 Q4 to 09 Q3. So the change, so the flows then versus the flows that they had in 2007, and there's a strong negative relationship. So the countries with larger gaps prior to the GFC had a larger decline in capital flows during the GFC. That outlier, any guess what that outlier is? Dun, 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 Hong Kong. If you take out the outlier, it's still just as strong. Could have guessed. All you have to do is read the bottom of the screen, right? One outlier, Hong Kong, but it's still strong. You get rid of Hong Kong, it's still strong, and it's very strong for EMEs and advanced economies that haven't had unconventional monetary policy. So KF Star, the gap, helped predict the amount of flows that countries would get during the GFC. And so then we say, all right, let's, on the right side, think at the eve of the pandemic, where were countries relative to KF Star? You see where zero is on that. Most of them were negative. So that is, most countries in 2019 had portfolio inflows that were below KF Star. That is, we weren't seeing in 2019 an exorbitant amount of capital inflows into a lot of these countries. And that would suggest that for many countries, we don't expect any drop in capital inflows in 2020 to be long-lived. We think it should be short-lived because they're already below KF Star. And so the flows should, as we normalize, the flows should come back to KF Star. There are just very few countries you can see that have positive gaps in 2019, and the most positive ones in Asia were Indonesia, China, and the Philippines, and they were all just slightly positive. They weren't that positive. So this analysis would suggest that decreases during the pandemic, decreases in capital flows could certainly be severe in a quarter, a couple quarters, but things should bounce back. Good. So I've gotten through my outline, and so I will just conclude with some of the conclusions. This KF Star does appear to represent a natural level of flows, and even though quarterly flows are really volatile, they do seem to oscillate around KF Star. These Cogley tests show that the deviations of actual flows from KF Star are transitory. The flows revert strongly back to KF Star over a 1 to 2 year horizon. It also means that the deviation of flows from KF Star actually gives us a lot of explanatory power in explaining where flows are headed over the medium run. It performs pretty well against various filters, various other methods, predicts 6 quarters ahead sudden stops, next year's equity returns, predicted countries that had the largest declines in portfolio inflows. And so it's in our mind, it's a pretty exciting and strong measure. And I will stop there other than say thank you.
I think this is very, very exciting work, Frank. I have one question. In establishing KF Star, you relied on optimality in the statistical sense, in the sense of Cogley, which is a statistical procedure. Is there a way to relate this to optimality in the economic sense? The sense of Lucas, for example, the Lucas paradox. The Lucas paradox says, why don't Why doesn't capital flow to emerging markets? Why doesn't capital flow to the faster growing economies? Can you relate maybe the benchmark or the KF star to what might be considered sustainable capital inflows to a fast growing economy?
We have not thought about that yet. And so our colleague here at University of Virginia, Anton Kornak, who's a great mind on these things, is pressing us in that direction. But we have not thought yet about optimality in a economic sense. From our perspective right now, what KF Star tells policymakers is the amount of flows that they can expect to receive in a quarter, in a year. And so when you see big deviations from it, it says to us that you shouldn't get too excited about it because statistically, it's going to come back to KF Star. And so don't think when there's big deviations that that's going to be necessarily the new normal. Again, statistically speaking, these flows, however volatile they always come back to KF Star.
Hans has a question. His question is, in the case of deviations from KF star, could this reflect deviations from, deviations from an optimal portfolio allocation?
Yeah, so I'd have to ask Hans to define optimal portfolio allocation. So this is one that we've struggled with. So we've been pushed to come up with a KF star that comes from optimality conditions, CAPM or other. You can think about consumption covariances, different ways. The problem that you run into is the home bias, right? The pretty extreme home bias. So even though the home bias has been lessened over time, it's still so large in almost any of these models that the measure that you would get from that would it wouldn't be anywhere near where the capital flows are, right? So we've tried that, and it's failed so miserably that editors always tell us to take it out. I think this is a way. I mean, so this is built from theory, right? KF star is built from theory. I didn't stress that, but the theory of Cedric Thiel and Eric Van Winkoop, Mick Devereaux and Alan Sutherland, when they brought portfolio choice into DSG models in their 2011 papers, that's the basis for KF star, right? So they didn't really apply it. Those were much more theoretical papers that were focused on the mathematics of solving the model, which was obviously it was a huge undertaking. So KF star does come from theory and from optimality in those models, but I think Hans's question is more about something like a CAPM, or even so in Devereaux Sutherland, it comes down to consumption covariances. Even if you go that route, you're still going to get weights that just have nothing to. I don't want to say have nothing to do with reality. They're far from reality, and so from a practical perspective, it's not as useful. So Anela had a question. So yeah, so Anela's question is about time variation in the weights, and we haven't looked into that yet. And that's one reason that we go with the 5-year lagged moving average, because it just doesn't move that much. The weights don't move. That 5-year lagged moving average of weights, it could be trending, but it's not very volatile. And so it's smoothed out, and it's similar to, again, what CBO does when they're trying to come up with potential GDP measures, and they've got very volatile capital and labor shares, and so they smooth it out. They run it through a filter to smooth it out. The weights themselves, Anela, we could certainly try to model, right? I mean, actually, probably a bunch of my other papers are in some sense about those weights, right? And trying to think about portfolio shares. But we could certainly model that. We haven't done it yet.
Now, Frank, it's not quite the same thing, but there's a World Bank paper that tried to model credit and sort of equilibrium credit by using a long-run co-integration analysis. I mean, it's sort of maybe not a fruitful area to explore, but I mean, I was wondering whether that's sort of an approach in terms of the equilibrium, some theory-based equilibrium capital flows. I remember in earlier versions of the papers, you made all the data available on your website. Is that still the case?
We will. We absolutely will. So this version. Slide 2 said this version is the September 15th, 2020 version. So we're still writing it, but absolutely, yeah. So all the data in the code will be posted. All the data in code are posted for the 2018 paper, and we'll post this as well. And there's nothing difficult about the data set at all. It's all publicly available stuff, but all the data code and data will post definitely. And I don't think I stressed this, but the whole reason we did this was so that policymakers, when they're confronted with really volatile flows, they have some anchor, right? Because otherwise, if you just have no idea where the flows are headed, and so that we want this to be useful. We want people to use it. And that's one reason that we make the data available as fast as we can.
Frank?
Yes.
The result that a positive gap predicts negative equity returns. That's very striking because returns in the equity market are not supposed to be predictable at all. Can you speculate on a mechanism for that, why that would be the case? That's one question.
Yeah.
I have a second question, which is, I forget my second question, Frank. Why don't you?
I'll answer the first one first, and then we'll see if we get to the second one. So the mechanism. So one, when you lengthen the horizon, then the equities become a little bit more predictable, right? So we're at a 1-year horizon, and so there is definitely some predictability in equity returns there. So it's in that sense, Ali, it's similar to exchange rates, right? If you go out further, it's easier to predict them. If you try to predict them very short term, it's very difficult. Same thing with equities, and so it's so. The R squareds we're getting 0.15 R squareds on these equity returns forecasting exercises. They're good, no doubt about it, but not huge. The mechanism is similar, so it's actually somewhat similar to the BIS analysis of credit gaps predicting future crises, right? And it's kind of similar, right? So the credit gap is they have an HP filter for the HP filter is their sort of credit star, right? If you want, right? Their credit star, and then they have the actual non-financial debt, the credit number, and when the actual is higher than the HP filter, that predicts a coming crisis, right? And so it's the same sort of thing here, right? When the actual is higher to KF star, and KF star is increasing strongly because global growth is increasing, you're likely to get a sharp decrease in capital flows, come back to KF star. That sharp decrease in capital flows would naturally put downward pressure on equity prices, right? So it could be other things going on as well, but just the sharp drop in capital flows could put downward pressure on the equity prices.
Actually, that's related to my second question, which is maybe they're the same thing, predicting a sudden stop and predicting negative equity returns. In the BIS work you mentioned, large capital inflows tend to lead to excess borrowing.
Yep.
What we call a credit gap that exceeds a threshold.
Yep.
And so they may be related.
I think they are. So at least the way I think about it is very similar. So I think they are. Good. Anela has a question that I'll try to answer offline because I don't know the answer, Anela, on the net flows and net savings, and we struggle with. So it's about Anela's questions. It's about the unconventional monetary policy countries, and they are big countries, and how we should think about them, and we struggle with that. So at this point in this paper that is very much work in progress, but getting close, we're happy that we can at least see that for non-unconventional monetary policy advanced economy questions, advanced economy countries, it works well, right? So at least we've identified where it doesn't work well. And then, Anela, where it really doesn't work well for the UMP countries is their debt inflows are so far below KF star. And so that is that in part is what UMP is trying to do, right? Is to divert debt flows from those countries, and that's what seems to be happening. It's not on the equity flows that they're below KF stars; it's the debt flows. Let's see.
Oser has a question on whether there can be shocks to KF star itself. Is it smooth all the time? Does it?
It is smooth. It would take, because it's a lagged. So the global savings is pretty smooth, right? So the savings number is pretty smooth. The weights, if we didn't use a 5-year moving average, those would be volatile, right? Because they'll move around with valuation changes and things like that as well. And so with the 5-year lag moving average on the weights, it's not very volatile. But you're absolutely right, and a few others have pushed us in the same direction tonight here. Let's go this morning. That we really have to do more analysis of changes in the weights.
Okay, with that, shall we leave it at that? It is 10:03. I'm aware that it's 10 a.m. our time, but it's 10 p.m. in Virginia. So if I may, let me thank, first of all, Frank for agreeing to do this. He's been, this work was first presented at an IMF Bank workshop. So there is a Malaysian connection, if you like, to this work. And in fact, we at the SEACEN Center, we've been watching it very closely. We were fortunate enough to have Frank and Veronica join us a couple of years ago as visiting scholars, and they spent a week with us and thinking about KF star. We think it's a really useful concept. We advertise it as much as we can, or we advertise it whenever we can, in terms of being, as Frank said, a very useful guide to thinking about capital flows. And you will hear a lot more about it going forward. So if you're coming to our capital flows course, there will be a session on KF star on this. So a big thank you to Frank for doing this. A big thank you to the ASB for organizing this session as part of our ongoing webinar series. So thanks to Ellie and Daniela and everyone working in the background. And obviously a big thank you to all the participants who joined us this morning to listen in, to put Frank through his paces, ask difficult questions, and hopefully make the paper even better and even more useful. I will stop here. Let me thank you. Let me also thank Uzair for all his inputs into this, with more to come. I hope we have whetted your appetite if you're new to this series. Next month we are joined by Atif Mian, who will talk to us again about capital flows. And with that, I'll just shut up. I hope everyone is safe and healthy, and I hope everyone will stay safe and healthy until we meet again next month. Thanks a lot, and see you soon.
Thank you, Frank, and thanks to everyone who joined us. The paper will be made available, and the slides will be made available.
Yeah. Yeah. Thank you, Ellie. Thank you, Ali, and thank you, Uzair, for as always great comments, and Anela and Hans as well. And thanks. Really enjoyed this.